So let's see some examples of composition of functions in practice. Once we learn how to read the notation, then the only real issue is the fact that functions can be described to us in multiple ways. So we've seen functions described to us as tables, we've seen functions described to us as graphs, and we've seen functions described to us using algebra formulas. So we can answer composition of function problems in each of those three types. So I'll do an example of each one of these, and then you can pause the video and try the other ones, and I'll fill in the answers to the remaining ones so you can check. So when we see something like f of g of 3, like part A here, the most important thing is that the most important thing is not to freak out. But the second most important thing is to remember that we already have a rule for working with things with parentheses like this, which is we always work inside the parentheses first. And so that means that I'm going to leave this outside stuff, the stuff that's outside the parentheses, I'm going to leave all of that alone, and I'm going to focus my eyes just on the part that's inside the parentheses. So my first goal is to figure out what is g of 3. The thing that I've shaded there says g of 3. It's within the other parentheses, which tells us we want to do it first. And then to answer the question, what is g of 3, again, that depends on how g is described. In this case, g is given to us as a table, and so we're looking for the table for g, which is the one at the bottom. We're looking for the input of 3. G of 3 refers to the output of g when the input is 3. Input 3 would be here, and so the output of g when the input is 3 would be 2. So g of 3 is 2. So notice I've ignored the outside part of this. It still says f and then parentheses. That's all the outside parentheses. I've just figured out that when it says g of 3 in the parentheses, that really means 2. So now I just repeat the process. If I look at this statement, it says f of 2, and so that means the f function with input 2. So I can go to the f table, I can look for input 2, and I can find that the output when the input is 2 is 8. So f of 2 is 8. And so that's my answer to, we would read this, f of g of 3. So f of g of 3 is equal to 8. So now you try the other three, and I'll just fill in the answers. You might want to pause because they're just going to show up, and we'll move on to the next slide. Okay, here are my answers to these questions. Notice in letter D, you should have found that you couldn't really do it because you don't have the information given in G, and this is deliberate on my part because I wanted you to see the possibility here of what happens with the domain for these composition of functions. And we won't go into that in this section, but we'll come back to it later when we have more tangible functions to work with. But the point I wanted to make here is that the input 1 is completely fine for f. F of 1 is 6, so that's fine. But then that leads us to have to evaluate g of 6, and there is no value of g of 6. So what that means is that when you're chaining these things together, and this makes sense when you think of it as the sort of chaining together process, but the range of f here, in other words, the values that come out of f, have to match up with the domain of g in order to be able to get answers. So there has to be a relationship between the outputs of f and the inputs of g for us to be able to pull this off. And that's a good thing to keep in mind going forward, because we will see these composite functions again later on when the functions are more tangible and we can actually look at real domain issues. We can ask the same questions where the functions are described to us only in terms of graphs. So I'll do the first one and then let you pause and we can check answers on the other three. But the process I'm using is no different. I see f of g of 1, and I then say I got to work inside the parentheses first. And so f of g of 1 is f of something. And so my job is to figure out what is g of 1. So again, I need to go see where g is described. In this case, it's described by this graph on the right. G of 1 means the output of g when the input is 1. Remember, points on the graph are input-output pairs. So the point that I've highlighted there is the point 1, 3. The fact that 1, 3 is on the graph of g means g of 1 equals 3. Every pair of coordinates for a point on the graph is an input-output pair for the function. So g of 1 is 3. So f of g of 1 is referring to f of 3. I find f of 3 in exactly the same way. I'm looking for the graph of f. I look for the input of 3. So the point right here has input 3, output 6. The fact that that point is on the graph of f means f of 3 equals 6. And so I can evaluate this as 6. So give the other 3 a try, and I'll write the answers in. So these are the answers that I got for these questions. Now let's look at one more type of problem. Again, this is going to be based on the way the functions are described. So here is the type of problem that you're going to see the most in algebra and calculus. The other types do come up too, but these are the most common, where the outputs of the functions are described by an algebra formula. So in this case, this will seem most familiar. It's not as quick as the other ones because we're not just reading off numbers from the graph. We have to actually do some arithmetic and possibly even get a calculator out. But the process is exactly the same. So like before, when I see f of h of 1, I leave the outside of this alone and go inside the parentheses first. So I'm going to look inside the parentheses and I see h of 1. So my job first is to figure out what h of 1 is. In this case, h of 1 comes from just plugging a number into a formula. The formula says h of x is 3x plus 2, so h of 1 is 3 times 1 plus 2, which is 5. So h of 1 is 5. F of 5, because we're given an algebraic formula for f of 5 is going to be the result of plugging 5 in to the algebra formula for f, so 5 squared minus 5, and that's 20. So the final answer here is going to be 20. So once again, you try the other 3, and if you pause, then you won't see my answers pop up right away, and then we'll be done with this part of the video. Okay, so you can see my answers to each question. Notice over on the right-hand side, I'm doing my scratch work to do the arithmetic for the initial step of figuring out what the inside number is. I left it there so you can see that that's not something that you have to do in your head. You don't have to do this problem by sort of figuring out numbers in your head as you are doing the computation. There's no shame in writing down some scratch work over on the side, and that'll help you not feel like you've not messed up in the calculation. The second one, plugging the -2 into a formula with a square in it, that one is particularly challenging. But let me just point out that when I do that, what you see here, you'll see I wrote down f of -2. Notice how I just copied down exactly what I was going to do, and the key thing that I did there is when I put a negative number in for the variable, I carried my parentheses with it. So carrying the parentheses with the -2 ensures that if I were to type that in my calculator exactly like that, then I know that I would have the right answer for that.